Hi, Logic students. I'm sure you've seen that Chapter 6 is a bit more complicated, so I thought I would make some video lectures and demonstration of exercises so that some things are clearer. This is new software that I just installed. I hope everything is working correctly, and please let me know how these lectures may be improved for you. I trust that you'll be able to see in these videos the screen of my computer as I see it, and I'll be able to scroll or to toggle back and forth between Applia and this other screen where I will demonstrate some things. There are different types of exercises in section 6.2, and you already tried a few of those. I just want to make sure that you understand how to go about doing these problems, which will also be in the homework. In the first block of exercises, you can see that the task is to identify the main logical operator. So let's take number 1 for example, and this is something I can try to write down in the other program as well. I can just try to copy it down, and then I can show you how to try and identify the main connective. So this one would be it's not the case that, wait, it's not the case that A or M, and it's not the case that if C, then E. So, and the reason I'm writing it down is that this way I can sort of show you where to look. The rule of thumb here is to identify that logical operator that is not enclosed within a set of parentheses or brackets or braces. And you know, the candidates obviously are this one, the dot, and the other tilde. But I think you can see that this tilde actually operates on this parenthesis. It says that A or M is not the case. And this other tilde does the same thing on the other side. So it says that it's not the case that if C, then E. So what remains is that the main logical operator is this one, the dot that is in the middle of the two formulae. Okay, so it's fairly clear at this point that this is a conjunction of two statements, not A or M, and not if C then E. So clearly this is a statement where the main logical operator is the dot. Let's go to another block of exercises in the same section. So here in section 2 you have to write down these statements. You have to translate them in symbolic form, and then you use your knowledge of history and other facts in order to be able to determine whether these are true or false statements. Okay, so this should be fairly straightforward. All you have to do is do the symbolization and then evaluate the statement. Let me take number 6 here. Alexander the Great civilized America if Napoleon ruled France. And let's see how we can do this one. Oh, too big. Let's try to make it a bit smaller here. And I can make more room here. Alexander the Great civilized America if Napoleon ruled France. I think you can see that this is a conditional statement. It's a statement that says if this, then that. So if Napoleon ruled France, that's the if part. So we put if first. It'll be N, if Napoleon ruled France, then Alexander the Great civilized America. So we can pick A for that statement. So the symbolization would be if N, then A. And here you have to remember that the truth value of this statement is a function of the component parts. So to determine whether the whole thing is true or false, you have to look at whether N is true or false and A is true or false, and then you match this with the truth table for the conditional. Alexander the Great, well, let's start with the antecedent. Napoleon ruled France is true, and Alexander the Great civilized America is false. So this is a conditional that has a true antecedent and a false consequent, and you know from the truth table for the conditional that then the whole statement is false. So just remember to apply the truth table for the conditional. And this is something that is explained, of course, in our textbook. So you just go to the relevant section where the truth tables are discussed. Oh wait, it's not this one, it's a little bit further back. Look at the truth table for the conditional. There it is. When the antecedent is true and the consequent is false, the whole statement is false. So that's exactly what we had in our case. N is true, A is false, so the whole statement is false. Okay, so this is another type of exercise. And then the most interesting and complex ones, and the ones that we can learn the most from, are the ones that are part of the third block of exercises, because here you really learn how to compute the truth value of compound propositions, some of them pretty long and complicated, from the truth value of the components of those propositions. Let's try number 14 together. And this will demonstrate the method that you use for all of these. A bit more room. Make this a bit bigger. I said number 14. So number 14 is, it's not the case that X or not B and not Y or A. So not X or not B and not Y or A. In this exercise, it's been stipulated that X and Y are false and A and B are true. So what you want to do is you start by reporting this under each letter. So X is false and Y is false, B is true, and A is true. And the way you do this is you work from the inside out and from the more basic to the more complex. So you cannot really say anything about this dot just yet. What you want to do is first you compute the truth value of the negations, because these negation signs apply directly to the letters here. You can't do anything with this negation just yet, but these two apply directly to these letters. So if B is true, not B is false. And if Y is false, not Y is true. Okay. Now you can work inside the parentheses. Right? This one is not relevant anymore because B is true, but what you're dealing with is not B, which turned out to be false. So now you're dealing with a disjunction, an OR statement, where both components are false. So false and false give you false for the disjunction. What is inside this parenthesis, X or not B, is false. Over here, it's a disjunction. This part is true. The other part is true. Again, this is not relevant anymore. True and true for the disjunction give you true. We don't want to move to the attack of this dot just yet because the formula on this side is a negation. The main logical operator is this negation sign. And this negation reverses the truth value of what is inside the parentheses. So if x or b of not, x or not b is false, then that means that not x or not b is true. This tilde reverses the truth value that was under the wedge here, the OR sign. Okay, so now the two places that are relevant are the truth value of the whole first formula, not x or not b, which turned out to be true, and the truth value of the second formula, not y or a, which turned out to be true. True and true with the dot give you true. So the whole statement is true. I hope this makes sense and demonstrates how you go about solving these exercises. So remember, first process the negations that apply directly to single letters. Then work inside the parentheses and figure out the main connectives. So here the main connective is this one, or the main operator is this one. Over here the main operator is the wedge. And then you put them together, true and true, and you get the truth value of the whole thing. I hope this is helpful. Let me know if I can do more to clarify these things, and you can use email or just post something in the OnCourse forum. But I hope this will be useful to you. Thank you very much.